Welcome to Algebra 2, Unit 6, Lesson 12. Here is a graph of f given by f of theta equals tangent of theta. Number 1, are pi over 2 and 3 pi over 2 in the domain of f? Explain how you know. So you need to remember that tangent equals sine divided by cosine. So number 1, no, they're not in the domain. If you look, you actually have asymptotes at these two numbers, where the graph will get closer and closer and closer, but will never actually touch. And the reason is at pi over 2 and 3 pi over 2, cosine equals 0. And you can't divide by 0. Number 2, what are the theta intercepts of the graph of f? And explain how you know. Well, notice there's an intercept at 0, there's an intercept at pi, and there's an intercept at 2 pi. So the intercepts are integer multiples of pi because sine is 0 at integer multiples of pi and 0 divided by anything is 0. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. The function f is given by f of theta equals tangent of theta. Which of the statements are true? Select all that apply. Choice A says f is a periodic function. If you look at the graph from our previous problem, you can see that this is, in fact, a periodic function. It will repeat the same pattern over and over again to infinity. So A is correct. Choice B says the domain of f is all real numbers. But if you look at the graph from the previous problem, you'll remember that we have asymptotes at pi over 2 and 3 pi over 2 and every half integer multiple of pi. So B is not correct. Choice C. The range of f is all real numbers. What I'd like to point out is that each line segment will get closer and closer and closer to these asymptotes without ever touching. They will go up to positive infinity and they will go down to negative infinity. So the range is all real numbers. So C is also correct. Choice D says the period of f is 2 pi, but choice E says the period of f is pi. If you look at the previous graph, you can see that it repeats itself every pi. So here we went from 0 to 2 pi, and you had half, a full, and another half. So the period is actually pi for tangent. So E is correct, and D is incorrect. So the correct statements for this practice problem are choices A, C, and E. If you have any questions about how I solved these practice problems, please use class time to ask for further clarification. Here is the unit circle. If tangent of A is greater than 1, where could angle A be on the unit circle? So remember a couple of things. Tangent equals sine over cosine, or y over x. So, if we want tangent to be greater than 1, two things must be true. Y and x must have the same sign. We either need to divide a whole number or a positive number by a positive number, or we need to divide a negative number by a negative number. The other thing that must be true, y must be greater than x. If y and x are equal, then tangent will be 1. And if x is greater than y, then tangent will be less than 1. So both of these statements must be true. So we could be in quadrant 1 because x and y are both positive. We could not be in quadrant 2. In this quadrant, x is negative and y is positive, so we would end up with a negative tangent. And the opposite thing happens down in quadrant 4. In quadrant 4, y is negative and x is positive. So if we tried to put it here, tangent would also be negative. So we've eliminated two areas. Now we know that we need y to be greater than x. So the halfway point on each of these would be at pi over 4 and at 5 pi over 4. So if we look in this bottom half of quadrant 1, x is going to be greater than y. So it cannot be in this area. And if we look over here, in the top half of quadrant 3, we're going to have a negative x that is bigger than the negative y, so that would cause it to be less than 1. So it can't be in this area. So the only areas left angle A must be between pi over 4 and pi over 2, or between 5 pi over 4 and 3 pi over 2. Anywhere in this green shaded area or this green shaded area could be correct. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Here's a point on the unit circle. Number 1, explain why the line going through 0, 0 and P has a slope of 1/2. If you notice, this makes a triangle where y equals 1/2 and x equals 1. Slope is change in y over change in x. So 1/2 over 1 equals 1/2. So it has a slope of 1/2. Number 2, what is the tangent of the angle represented by P? Explain how you know. Well, tangent is y over x. So 1/2 over 1 equals 1/2. Tangent is slope. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. It is 3:00 a.m. Number 1. What angle will the hour hand rotate through in the next hour? Explain how you know. The hour hand is going to rotate from the 3 to the 4. The angle is negative pi over 6 because it's a clockwise rotation of 1/12 of the full circle. Number 2. What angle will the hour hand rotate through in the next 12 hours? So in the next 12 hours, it will rotate from the 3 all the way around back to the 3. The angle is negative 2 pi because it's a clockwise rotation of the full circle. And number 3, what angle will the hour hand rotate through in the next 24 hours? Well, in 24 hours, it'll make 2 full rotations around the circle. The first rotation will mark 12 hours, and another full rotation will make it 3 a.m. the next day. The angle is negative 4 pi because it's a clockwise rotation of 2 full circles. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. For which angles theta between 0 and 2 pi is cosine theta less than 0? So to show this one, I'll draw the unit circle. And what we know is that cosine is the x value. So if I want cosine, which is x, to be less than 0, I cannot be in quadrant 1 or quadrant 4, because over here, x would be positive. So this means I need to be in quadrants 2 or 3. So to make this true, theta needs to be between pi over 2 less than theta less than 3 pi over 2. All of these angles will give us an x value that is negative, therefore a cosine value that is less than 0. If you have any questions about how I answered any of the practice problems on this worksheet, please use class time to ask for further clarification.